Okay, welcome back, ladies and gentlemen. There's some additional information I felt like I needed to add before we move on to any other graphs. And the additional information has to do with other types of graphs that you're likely to come across. Okay, so we already stated that we got the y equals to mx plus c, which is the extended form. Okay, but we need to agree on something, that if our c is 0, okay, so if our c is 0, then our graph will be y is equals to mx plus 0, so it's got like a silent 0, which we're going to show there. Okay, so if this is the case, then our graph has to pass through the 0, because that's what c is. It is where the graph cuts the x-axis, the y-axis. So our graph would pass through like that right there. Okay, and what the m does is that it changes the slope. It makes it either steep or gentle or 90 degrees depending. Okay, and then the next thing that we also need to look at is that what if our graphs are like this? Okay, I've drawn 3 lines there. Now if you notice, for the first one, I'm going to call this one 1, 2, 3. So let's assume that this is 4, this is minus 6, and this is at 0, of course. And we're asked to find the equations of those graphs. Now if you notice, our graphs are pretty much, they are parallel to the x-axis, so which means that they do not cut the x-axis, especially if you look at 1 and 2. But for 1, because it does not cut the x-axis, it means that from our y equals to mx plus c statement, this has to disappear because there is no x where the line cuts through it. So because of that, the equation of this is just going to be y equals to 4. Same thing, when you look at the one at the bottom, it's going to be y equals to minus 6. That's the equation because there is no place where it actually cuts the x-axis. Similarly, if you go through the number 3 is directly on the x-axis. So what that tells you is that the equation here is going to be y equals to 0. And that means that the equation of the x-axis is y equals to 0. In other words, anywhere on the x-axis, y is equals to 0. Okay, you're going to see how we use this later on in solving equations for where 2 graphs meet or something like that. Similarly, for another graph, okay, so we go graphs 1, 2, graph 3. Okay, and we'll assume that this is negative 4, this is 6, and of course this is 0. Okay, so these graphs are parallel to the y-axis, especially for 1 and 3, and because of that, their equations are not going to involve or include. They're not going to include the y because they do not pass through the y. They're parallel to it. They will never meet the y. So in essence, your graphs are going to just be equals to x is equals to 6 here. And that's the equation there. And then x is equals to minus 4 there. And as you rightfully guessed, the y-axis is just going to be x equals to 0. Okay? So that means that the equation for the y-axis is given by x is equals to 0. Again, this will benefit you in understanding how to solve equations, especially for the parts where they cut the x's in later videos. Okay, thank you very much, ladies and gentlemen. Thank you very much for joining us, and enjoy the rest of your day.